A firm can always trade 3 units of labor for 1 unit of capital. So that is 3 units of labor means 3L and 1 unit of capital means 1 times K. Capital is machinery represented with K, and still keep the output constant is very important. Output is constant. The production technology for this firm can most suitably represented by the given options are Cobb-Douglas production function, Lane-Toff production function, and linear production function. From these options, which one is correct? So a firm can always trade A, that is the output Q equals to in terms of 3L plus 1K. This is the production function. So function is represented in terms of input variables. Here the input variables are labor and the capital. So what are the different type of production functions? So first one is Cobb-Douglas production function. So how we represent the Cobb-Douglas production function? So in Cobb-Douglas production function, CDPF is exponential form, that is Q equal to the output of the form Q equal to L power alpha and K power beta. L power alpha and beta are the elasticities of the labor for respective labor and the capital K. So it is a power function, L power and capital power. So this is not the Cobb-Douglas production function. So because it is in this form, because here the given question is 3 times L and 1 times K, so it is not in this form, so this option is not correct. Next, Lane-Toff production function. What is meant by Lane-Toff production function? LPF, Lane-Toff production function. In Lane-Toff production function, the firm output Q is represented in terms of input parameters labor and the capital, which is the minimum of AL, BK. This is the standard representation. So here L is the input and K is the labor input. K, L and K are both are inputs. A and B are variables. So here the main difference between this linear production function and the Lane-Toff production function, here we use fixed ratios, that is fixed proportion of L and K, that is labor and the capital. So this option is also not correct. Lane-Toff production function is also not correct because the production function is minimum of AL, BK. The third one is option C is correct because linear production function. So in linear production function, the firm output, that is Q, is represented in terms of AL plus BK. Very important this one. So because which is in the form of given 3 times of labor plus 1 times of capital. So this is in this form. So this option is the correct. Linear production function. So what are we will learn linear production functions properties. So linear production function properties. First one is straight line isoquants. That is the isoquants are linear slope. So the isoquants. So here in this graph, x-axis represents the labor and y-axis represents the capital K. And for different production functions, the isoquants are like this, straight lines. These are isoquants. These lines are isoquants for production function Q1, Q2, Q3, which is the combinations of values, different values of K and L, input values. So these are linear slope production function. The isoquants are straight line. And the third property of linear production function is MRTS constant. MRTS is constant. MRTS is marginal rate of technical substitution. Marginal rate of technical substitution, which is the MRTS general formula is MPL, marginal product of labor by MPK, marginal product of capital, or another is change in slope of the delta K by delta L also. Is perfect substitutes. Perfect substitutes. So the linear production function perfect substitutes. And fifth property is constant return to scale. So all these are 5 properties related to linear production function. So there are 2 inputs. L is the labor and K is the capital, which represents the machine type. Machine is also a one type of good. So perfect substitute. Here in this question, the production function Q equal to 3L plus 1K. 3L plus 1K. That is 3 workers plus one machine. That is 1 unit of machine. 3 workers plus 1 unit of machine will complete 1 unit of output. 1 unit of output. And this output is constant. When it was constant, when we substitute 3L equals to 1K. That is, we can replace L with K, K with L. L and K both are substitutable. That is, we can replace 1K equals to 3L or 3L equal to 1K. The output is still constant. The output does not change. So the output does not change. This type of production function is called the linear production function. So here the linear production function, the perfect substitutes means we can replace L with K and K with L. That is, the output is constant. The linear production function Q equals to AL plus BK. So here L and K are independent. L and K are independent. That is, L depends on A and K. A and B are variables. L and K are independent. If we add an extra input, that is, we add an extra unit of labor adds A units to output. If we add an extra labor to labor L, it adds A units to output. If we add an extra capital, for example extra capital, it adds B units to output. That is the Q. So if we do dou Q by dou L equals to A and dou Q by dou K equals to B. This is MPK MPL. If A greater than 0, A is greater than 0 and if every unit of A will increase the output by A units, A amount of units. That is, if A greater than 0 and if we increase the labor also, that implies the output is increased by A units. Do you understand? So here in this equation, if we increase the labor Q equals to AL plus BK. If we increase the labor, so the output is also increases. How much amount? A times increases. If we increase the capital, K and increase, this will increase the output Q by amount B. So these are increased independently. These are not dependent. These are independent. So because of this, L and K are perfect substitutable in linear production function, but not in length of production function. How we will show? For example, Q equals to 2L plus 3K. If L equal to 5 and K equal to 4 and Q equal to 5 2s are 10 plus 12, that is 20. If we increase the labor, that is if we increase the labor, L equals to 6 and K equals to 4 and Q equal to 12 plus 12, that is 24. So the output Q is increased from 22 to 24 just by increasing the only labor. That means if A greater than 0, that is MPL A greater than every extra unit of labor, that is if we increasing the labor, the output is Q is increased by A units, A amount of units, and the capital does not need to increase the labor to produce the output. That is only if we increase the labor, the output Q is increased by A units, and the capital does not require to increase the labor to produce the output. But in length of production function, both L and capital are increases, only that time only output increases. So that is linear isoquants. So what is meant by isoquants? Isoquants are, these are the curves, represents the combination of L and K, different combinations of L and K values. So isoquants are linear in linear production function. LPF, the isoquants are linear. You have to remember like this. Linear production function, the isoquants are linear. What are the isoquants? Isoquants are different curves. That is the combination of different values of L and K values. For example, L and K, different values 10, 10, 12, 8, 15 and 6, 20 and 4. That is different values. The output is Q is still constant, same values 100, 100 like this. If we draw the each point represent L and K, the isoquants are like this for different production functions. These isoquants are linear isoquants. What are isoquants? Are just curves. And there is a property related to isoquants. These isoquants are convex to origin. Property related to isoquants. To origin means if we, as we move right side in this direction in the graph, the substitution of L and K becomes very hard. This is convex to origin. This is called convex to origin. From these curves, when we move the right side, the curves becomes flatter. So these are very hard to substitute. That is, we can replace L and K with L are difficult, hard. This will lead to the diminishing MRTS, marginal rate of technical substitution. Diminishing MRTS means decreasing. That is, K capital is decreasing. This is called the diminishing MRTS. In isoquants, when L increases, K is also K must increase. If L increases, K must increase. When we move the right side to the graph, that the graph isoquants becomes flatter. Because of this, when L increases, K decreases. This is called the diminishing MRTS. MRTS is related to length of production function. Length of production function. Output is constant in linear production function. And 3L and K, if we replace 3L with K, 1K and 1K with 3L, so that is perfect substitutes. And the production function, properties of the linear production function, straight line isoquants and linear slope, and MRTS is constant, MRTS value is constant, and perfect substitutes. Constant return to scales means, you know that constant return to scales means if the production function f in terms of L and K, if we multiplied with some constant positive value constant t, that is f of t L comma t times K, and the output becomes f a times TL plus b times tk. If we common the t, al plus bk, so which is the t times this one, right? F of L comma k, f of L comma k. So this is the constant production function, constant return to scale. This is called the constant return to scales, CRTS. If both are equal, that if we multiply the inputs with a quantity t, the output is also multiplied with the quantity, that is constant output return to scale. So these are the properties of linear production function.